Guys, watch. A lot of you are on the right track. You're making little errors. But remember, those little errors add up on the test. Right? Okay. Dividing fractions. Easiest pie. Flip the second and multiply. So, sorry, I got to read that. So guys, isn't this? So we have 2x squared over x squared minus x minus 2 times x plus 1 over 4x squared minus 2x, right? Yeah. Now, is anyone mad? We know in multiplying fractions, we literally multiply straight across. So I'm just going to throw parentheses in. Is that okay? Yeah. Okay, perfect. Now, we're to the last step. We simplify. Well, how do we simplify? Factor the top, factor the bottom, divide out exact factors. Now, one thing I want you to notice, this is really important. Would it be smart with these type of problems, we already know the answer, to multiply this out? No. Because then when we refactor it and have to end up back here, which on bottom, it's going to be near impossible to figure out how to factor that back down to this. Okay, so with multiplication and division, we're not going to multiply it out. We're just going to factor it. So the top fact is already factored. And then on the bottom, factor it in sections. So what does that piece factor to be, everybody? X what? Perfect. And then, isn't this a times sign? So then, we're going to pull out a what here? Now, I could write 2x right there, but can't I put it in front if I want? So then left is, that's where a lot of people messed up. They just went accidentally when they did you catch that? Okay, perfect. So now, it doesn't say restrict, but for multiplication and division, let's go ahead and do it. So very quickly, x cannot be what for that piece? 0? Perfect, and we can divide out exact factors. Now, once again, we can divide across a multiplication sign as long as it's not connected to an addition sign, right? 2's divide out, x squared and x divide out to become an x on top, x plus 1's divide out, so we have x on top. Okay, hopefully you were able to catch where it was that you went wrong. Okay, very good. Okay, erase your whiteboard. The video, talk about it. So this piece, you would say, oh, that's 2 perfect cubes. So you cube root the front thing, you get at x. Cube root the back thing, you get 2, right? Now you have to do the front times the front times the back times the back. Then this sign is the same as the original sign. The next sign's opposite. The next sign's always plus. That was just that piece. Now we're multiplying straight across. So I guess I should have just went like this. Am I right? Same thing as rewriting it, right? So then this piece factored to be what? And then you would say to yourself, does this quadratic factor, so what multiplies to be 4 and adds up to be 2, 1 times 4, 2 times 2, so nothing, and Hannah pointed that out to me. Well, this one doesn't factor, so we're good to go, right? Yeah, right. And then on bottom, let's factor out this to be, this is a times sign, so it's still a times sign, and then what would we pull out here? X, and then left is x squared plus 2x plus 4, which we know doesn't factor. And now, because I didn't say restrict, I did say save the excluded values. We don't have time. For here, because it doesn't factor, we wouldn't exclude. Now we'll divide out exact factors. So x minus 3 over x. Okay, good job. Really, for a lot of you that got that were close, good, very good. I'm really impressed. Okay. All right, now we're going to talk about this very quickly because you could be tested on it. This is what we learned last time. What's the saying? Dividing fractions easiest pie, flip the second, and multiply. Now looking at these, do you see how they look almost the same to start out with? Yeah. The question is, do they simplify to be the same thing? Well, let's see. You say no, let's show yes or no by algebra. So let's do this. This is 9 divided by 2 on top. On bottom, isn't this 3 divided by 1? So flip the second and multiply would be this, wouldn't it? Does everybody see how this becomes this? So then we would have 9 over 6, which equals, they both divide by 3 and become a 3/2, guys. Right? Now let's simplify this one. Well, 9 is on top. What's really 9 divided by? 1. So we have 9 over 1 divided by 2/3. Flip the second and multiply. So what's going to be on top? On bottom? When we multiply straight across, we get 27 over 2. Does that simplify? So why are they not the same? Well, you would point out, because look, does that make sense, everybody? Try one by yourself now. I'm going to ask you a question. Are they the same? Yes or no, and why not? Really, the only way to show me why is to kind of do the algebra and say, see, look, I did simplify them, and they are truly not the same. Or they truly are the same. So isn't this, the hardest part is figuring out what's really the top fraction, what's really the bottom fraction. I would rewrite it like this. Flip the second and multiply. Now when multiplying, don't we just multiply straight across? So we're looking at this, and then that simplifies to be 1/2, doesn't it? Okay, cool. Then you would simplify this one once again, saying, oh, this is over 1, flip the second and multiply. So that means x plus 2 is on top. And then 2 is on bottom. So that would be x plus 2 times x plus 2 over 2. That would be an acceptable answer. Also, yes, good point. We could write it as x plus 2 squared over 2. And then we could also write it as x squared plus 4x plus 4. But why multiply it out when you don't have to? All good. You would say they're not the same, looks like. Because, well, look, this is why they're not the same. All good? Okay, let's go on to today's lesson. Okay, everybody focus for a second. Now, once again, this lesson's not hard by itself, and multiplication and division, you just shown me, is very easy for you. But what happens is, once you've learned both lessons, you combine the ideas together, and then it goes bad, bad, bad. So you've really got to kind of see the difference here and understand the rules of each. So paying really close attention. Okay, so we know, everybody listen, with multiplication and division, we do not need a common denominator. We literally just multiply straight across, right? Now, we also know with multiplication and division, we do not actually take the time of multiplying out all that stuff, right? We keep it factored, and then don't we divide out exact factors? That's going to be different when it gets to addition and subtraction. So here's the first rule. When adding or subtracting fractions, you must have a common denominator. That's very different than multiplying and dividing. So to be able to add these things, you need a common denominator. Now, a lot of people don't really get what we're doing here, and so I want to express to help you see what our goal is. Our goal is to take two fractions and have one fraction instead. That's prettier to have one fraction. Does everybody understand? So what we're trying to do is combine the fractions. Now, in order to do that, we've got to have a common denominator. So that's kind of the hardest part for people to get. Now we're going to want the least common denominator. Now why? Because if we find a common denominator, that's all fine and dandy, but the least common denominator is the best because the less is better. Less simplification is better, correct? So if we don't find a least common denominator, the end simplification is going to be near impossible when we get to these really hard problems. But it will be possible if you found the least common denominator. Does that make sense, everybody? So we're going to start out basic for a reason. So we have 2/3 plus 5/2. You don't even have to take notes during this because I know that you probably are good to go. I'm trying to make a point here. We need to combine this into one fraction. To do that, we need a least common denominator. This one has a 3, this one has a 2. So 3 times 2 is 6. My least common denominator is 6, everybody. So we need to make each of our denominators a 6. How am I going to make 3 a 6? Multiply by what? Now, notice I said multiply. You can't get a common denominator by addition or subtraction. It has to be multiplication. So we're going to multiply by 2. If you do that to the bottom, you've got to do it to the top, because then we're just multiplying by a 1. Does everybody see? So what right here, to make 2 6, what do I need to multiply by? 3 times over 3. And now our next step would be to, yes, multiply out the numerator. Here we go. What's 2 times 2? So we have 4 over 6 plus 15 over 6. Now look at your denominators. They're the same. The whole goal of getting a common denominator is so that we can then add up our numerator. Does everybody hear that? So what's 4 plus 15? So we have 19 over 6. That's my answer. Now would be the appropriate time to factor the top, factor the bottom, and divide out exact factors. Well, 19 doesn't factor, so nothing divides out, so that's our answer. Does that make sense, everybody? And then we would do that and then divide it out. Okay, so looking at the point here. A lot of people think, oh, well, you just multiplied by each other's denominator. Well, that is true for some cases, but not all cases. So, for example, 2/3 minus 5/6. We want to find the least common denominator. It is not 18. You could do 18, but then the simplification is going to be much harder. It's 6. Now, the reason you were able to so easily see that is because we're dealing with something really easy here, okay? So let me show you how you would do it, technically, so that when we get to the harder stuff, it makes sense. What you're technically doing is factoring out the bottom to see what's already in common. So we have 2/3 minus 5 over, we didn't factor the tops, just the bottoms to see what's already in common. 6 is 3 times 2. Now everybody look, do you see how they both have a 3 already in common? So we don't need to put a 3 or anything in either of these. The 3 is taken care of. It's still in our least common denominator, but they're both taken care of. So now look, I can cross this out. They both have a 3 in common. So what do we need? What's still left over? A 2. So times 2, our least common denominator is 6. So now we're going to have to make all of our denominators 6. So let's look at 2/3. How do we make this denominator 6? Multiply by 2 over 2. Isn't this one good to go? Now our next step is multiply out the numerators. So we have 4 over 6 minus 5 over 6. Our denominator is the same. So the next step is to combine like terms in our numerator. What's 4 minus 5? So we have -1 over 6. This would be the appropriate time to then say, I'm going to factor the top, factor the bottom, divide out exact factors. But obviously, we're just starting out with the basics here. Okay, let's get to some harder examples here. Write this down. This is where you would want to take notes. Okay, so once again, with adding and subtracting, the first thing you need to get is a least common denominator. And that really is the hardest part for people for some reason. So once again, you can only get a least common denominator by multiplication. So this one has a 3, we're going to need a 3. This one has a 2, we're going to need a 2. Then an x. So what's my least common denominator? 6x. Is everybody good? So make each denominator 6x. How are we going to make 3 a 6x? Multiply by what? 2x. So that's the top and bottom. And then right here, we're going to multiply by, we need it to be 6x, so 3 over 3. We're starting out with basics to make a point here. So then our next step is to multiply out our numerators. So wouldn't this be 4x squared? So we have 4x squared over 6x minus 15. We're multiplying out this over 6x. Now look at it. The denominators are the same. The whole point of doing that is so we can now combine our numerator. Now guess what people do? Before they combine the numerators, they go back and start simplifying. So this is what I see happen all the time. People will get here and go, oh, well, 4 and 6 divide out to be 2/3. And doesn't x squared and x divide out? Well, then don't you end up right back at the beginning? But I see so many people do that. Because they want to simplify. You cannot simplify this until the end. But you see how they get that confused with multiplication and division? That kind of makes sense. Okay, now combine our numerators. So we have 4x squared minus 15 all over 6x. And then we'd say, okay, now we can factor and divide out exact factors. Does anything pull out on top? 15 doesn't quite divide by 2, but good thought. So let's check. What multiplies to be -60 and adds up to be 0? Nothing. So we're done. If it doesn't factor, it doesn't divide out. So we're done. Okay, down here. Now look, once you've learned this, don't forget. Looking at this one, we have 2x over 3 times 5 over 2x. Do I need a least common denominator here? No, but a lot of people, once they've seen this lesson, get least common denominators with multiplication. Now looking at the difference so that you can see what I'm doing here. With multiplication, isn't it appropriate to just literally rewrite it over the same fraction and not multiply it together? Because then can we divide across a multiplication sign? So 5/3. So that's different. With addition and subtraction, we had to multiply it out on top. Yes. I mean, this was just a basic example, so I see what you're saying. Like you're just asking if you would have multiplied it together, yes. But if we would have had multiple terms, we wouldn't have done that, right? So we're just starting out with basics. Okay, so write down these examples here. So just start at the first one here. This is on a separate sheet of paper. I'm going to have you staple it to your homework. Yeah. If you don't do it, you get a 5 out of 10 instead of a 10 out of 10. Here we go. So just write down the first one. 4 over 3y plus 7 over 3y. When adding and subtracting, we need a common denominator. Condil. What's the point of having a common denominator? So that we can write this as one fraction by combining the numerator. So what's 4 plus 7? 11 over 3y. You'd say, that's my answer. Does my answer simplify? How do we simplify? Factor the top, factor the bottom, divide out exact factors. Nothing factors, so we're done. Starting out with basics so that the harder stuff makes complete sense and you don't combine ideas in your head. Any questions, please ask. Okay, write down the next one. 3x over x minus 2 minus x over x minus 2. As you're writing that down, once again, what should be going through your head is, with addition and subtraction, I need a least common denominator. This one already has a least common denominator. What's the point? Well, we don't want two different fractions. We would rather have one. So we can now combine our numerators. So what's 3x minus x? 2x. So we have a 2x on top, and on bottom, don't we have x minus 2? Now that we've combined like terms, it's the step where we factor the top, factor the bottom, divide out exact factors. Does anything factor on top? On bottom, no. So anything divide out? No. Can we start dividing across addition and subtraction? No. We learned that first lesson, all to put it into now. All good. This does not simplify. That's our answer, right? Okay. Write down the next one. 5c over 2c plus 7 minus c minus 28 over 2c plus 7. As you write it down, once again, the first thing that should be going through your head is, I need a least common denominator. Now this one already has a least common denominator, so the whole point is combining the numerators. But, right, there's a red flag. Well, why? Because I guarantee if you miss one, it's most likely going to be a subtraction problem of this caliber, this easy. Here's why. What do we know when we're combining like terms? Isn't that just remember when we... Why do we suck? So guys, aren't we subtracting all that stuff? Yes. Well, yeah, because aren't we now just adding polynomials back like when we did that whole first test? Does that make sense? So why is it a red flag problem? Because people miss subtraction. So there's really a -1 right there. So with the numerator, we have 5c, -1 times c is -c, -1 times -28. Plus 28. So that's our numerator. Combine like terms. 5c minus c is, so we have 4c plus 28 on top. And then on bottom, 2c plus 7. Now this is where you would say, I have an answer here, but now I've got to simplify. The steps to simplifying never change. Factor the top, factor the bottom, divide out exact factors. What can I pull out on top? 4. So then left is c plus 7. On bottom, I have a 2c plus 7. Now careful, we can only divide across multiplication. If it's connected to an addition sign, it would not work, right? Can I divide this 4 and this 2? No, because it's connected with addition. Does everybody see the difference? Can we divide out these plus 7s? No, you can't divide across an addition sign. So this is literally as simplified as this one gets. You didn't distribute the negative. You were the statistic. Never mind. You weren't the statistic. You just wrote it down wrong. It's okay to be the statistic because that means everybody does it, right? Okay, cool. Okay, now these ones are coming off of the front page of the worksheet down here. These are the ones you'll continue on your notes. Here we go. Let's just quickly go through it. So we have a plus b over 9b. Minus, anytime you see a minus sign, you should throw yourself a red flag because people miss subtraction like no other. Minus a minus 3b over 9b. Your first step is get a least common denominator. Isn't that done? So we already have a least common denominator. So now can we combine our numerator? So we've got to put a -1 right here, put parentheses, and go ahead and distribute. So let's do that. So from here, we still have a plus b. And now don't we have minus a plus 3b? That's our numerator. We're combining like terms. A minus A is gone. B plus 3B. So we have a 4B in our numerator. On bottom we have a 9B. You say, that's my answer. Now I've got to simplify. We simplify by factoring and dividing out exact factors. Do 4 and 9 simplify? No, don't make the mistake of square rooting them. You can only simplify if you're dividing by the same number. So we're good. Right there. But don't the B's divide out? We can divide across in a multiplication sign. So the B's divide out and we get 4 over 9. Okay. So let's do number 2. Once again, we have a common denominator, correct? So now we can just combine our numerator. So on top we're going to have, and isn't it kind of a good idea to write it in standard form? We can't factor things unless they're in standard form. So we have 6m plus 2 on top. And on bottom we have 24m squared n squared. You'd say, that's my answer, true, that is. But now you've got to simplify. So now, how do we simplify? Factor the top, factor the bottom, divide out exact factors. What should I pull out on top? There's not an m over here, though. A 2, divide by 2, divide by 2. Left is 3m plus 1, right? Now on bottom we have 24m squared n squared. Okay. Now you can divide across a multiplication sign. So let's be very careful. Well, yeah, the 2 and 24 simplify. So that's 1 over 12. So our final answer was 3m plus 1 on top. And on bottom we got a 12, an m squared, and an n squared. So you really do have to check to see if your final answer factors and simplifies. Okay, I want you to now try on your own 1, 2, and 3. And I'm just going to stay up here and then I'll see what you get. So it shouldn't take you long. For a second. Now you can start on the worksheet. No, you're going to still need that separate sheet for later, but yeah, we'll be switching back and forth. Okay, on the first one, what did you get? 4n. 4n? Okay, on this one you got? And nothing divided out? Interesting. And here? Negative 6 over x. Do I need to go through that one, or we all got it? You all got it? Sweet. We won't go through it then. Very good. Okay, now go back to your notes. Okay, this is what on your worksheet they're going to say, for example, what's the least common denominator? We're going to go through and actually add these up. So let's go off to the side, everybody. This really is the hardest part for people, is getting a least common denominator. Now to look at the least common denominator, let's factor out our denominators to see what's already in common. 6 is 3 times 2 times x, right? Plus 3 over 2 times x times x. So where I start with least common denominators is, what's in the denominator that's already in common? A 2 and an x. Does everybody agree? Now that's in your least common denominator, but it's already in common. Now what I would do is cross those out. We've taken care of those. Now what does this one have that that one doesn't? A 3, so we're going to have to put a 3 in our least common denominator. And then what does this one have? Another x. Now is everything crossed out? On bottom. Okay, so we found the least common denominator. It was 2 times x times 3 times x, which is 6x squared. Does everybody see how I found it? Okay, let's make all of our denominators 6x squared. 6x. How am I going to make it 6x squared? Times by x over x. Right here, I have 2x squared. How am I going to make it be 6x squared? Multiply by 3 over 3. Okay, let's multiply out our numerators. That's our next step. So we have 5x over 6x squared plus 9 over 6x squared. Does everybody see where I got that? Now our next step is to not just don't start dividing, or you're going to end right back up at the beginning. You do not simplify till the last step on this kind of problem. So now we combine our numerators. 5x plus 9 is on top, and on bottom we get 6x squared. Now factor the top, factor the bottom, divide out exact factors. Well, it's factored, or it's done. So nothing divides out. We're done. Okay. All right, see if you can do this one on your own. Find the least common denominator. And then go ahead and do the algebra in this one. Ask the people around you if they get the same least common denominator. This is where you should be starting. You should be saying, okay, what's already in common? Okay, so y squared. Now we've got to go and see what's left over that we're going to need to put in. A 7, correct? And 2 more y's, right? So we're going to need a 7 and y squared. And then in this one, what else? A 3. So times 3. So multiply, and we get 21y to the 4th. How many of you were able to figure out that 21y to the 4th was the least common denominator? Nice. Okay, let's fix it. What does this one need to become 21y to the 4th? Multiply by 3 over 3. What does this one need to become 21y to the 4th? 7y squared. The next step is multiply out your numerator. So we have 9 over 21y to the 4th minus 4y, number minus 14y squared, right? Over, I can't write this out. 21y to the 4th. Sorry. And now can we combine our numerator? How many of you wrote it in standard form? I would. Yes, good. I'm glad you did. So we would write probably negative 14y squared plus 9, wouldn't we? Probably. And then on bottom we have 21y to the 4th. Now our last step is factor the top, factor the bottom, divide out exact factors. So technically, if we wanted to be really technical here, can I pull out negative 1? Let's do it just because in future, this one happens to nothing simplifies, but it might in the future, and not pulling out that negative might be the problem that makes you get it wrong. But does anything divide out? Nope. And then if you multiplied out the quadratic, what multiplies to be 60 and adds up to be 0, I think, wait, is 14 times 9? Let's see. No, 126. Well, multiplies to be 126 and adds up to be 0, nothing. So we're done. Sorry, I can't for some reason. All right, cool. What I want you to do is work on these ones, check them off with me before we go on to the more advanced ones. So we're sticking with, don't do different ones that I don't put up here, because then you're going to ask questions I'll answer later, and it just takes away time from your homework time. Stick to these ones. Oh no, I knew that. Okay, so you got a least common denominator, which is 2d. So you multiply by 2 over 2, d over d. So then you would have 8 over 2d minus 2d squared over 2d. Then once again, now I would rewrite the top in standard form, negative 2d squared plus 8 over 2d. Then our goal is to simplify correctly, so you factor the top, factor the bottom, divide out exact factors. On top, you're going to want to pull out the greatest thing in common, which is negative 2. So then left is d squared minus 4. Now here's what a lot of people that were advanced thinkers said, I better factor that just to make sure it doesn't divide out with anything on bottom. So that piece became d plus 2, d minus 2. And then don't forget the negative 2, good point. And then on bottom we have a 2d. Now remember, you can divide across multiplication. So don't those 2's divide out? So we have negative, and then, or negative 1, but we just don't write negative 1, d plus 2, d minus 2, all over d. Now, if you would have had negative and then in parentheses d squared minus 4 all over d, you would have got it right as well. It's just this was in standard form where this is in factored form. Why is it wise to have it in factored form? Because then you know it didn't divide out with anything on bottom. Okay, are you able to do, are you guys good with those ones? Most of those ones? Can we move on to some harder examples? So we can get to some on the back page and stuff. Do you want some more time to work on those? Okay. 15, this one's an easier one, but I'm seeing a lot of people accidentally mess up. Isn't this 1 over 1? What's my common denominator? Multiply by y over y. So don't we have y over y plus x over y? So then don't we combine our numerators? Y plus x over y. Can I divide the y's out? No, we can't divide across an addition sign. Okay, sweet. Let's go on to some harder examples here, just because we'd rather go slower through these harder ones, and then it might make the easier ones click better. Okay, write this example down. So we have 9 over n plus 2 plus 8 over n minus 7. So what happens is people kind of try to get common denominators by addition and subtraction, but you can't. You can only get a common denominator by multiplying. So what I mean by that is people will go like this. Add 9, add 9. You can't do that, because wouldn't that make the bottom 2? Yes, that's just, you can't do that, okay? You can only get a common denominator by multiplication. So, one other thing to note, a lot of people will say, well, they have an m in common. No, that's m plus 2. So, the least common denominator, the only way to get the factor m plus 2 is to either already have m plus 2 or multiply by m plus 2. Does that make sense? Because it's connected. And then also n minus 7. There's our least common denominator. So what does this denominator need? n minus 7. Now, next rule, if you ever have two terms like this, you need to put parentheses. m minus 7, what do I need? m plus 2. Once again, if you don't use parentheses, you'll end up getting it wrong. And now your next step is to multiply out your numerator. Combine like terms of the numerator and then simplify. Yeah. Each other's denominator. This one, they didn't have anything in common, so we had to do that. But there will be ones in the future that have stuff in common. So it kind of is a coincidence, depending on the problem. Oh, right. Gotcha. But it's like the 14 part won't matter here. Okay. 9 times m is 9m. 9 times negative 7 is negative 63, and that's all over m minus 7, m plus 2, right? Right? 8, no, we wouldn't want to then simplify because then we'd end right back up at the beginning, right? No, you're not the only one. I just had half of my honor students do that on their test and fail it. So we have plus 8m plus 16, correct, everybody? Yep. All over m minus 7 times m plus 2. Now, once again, what people want to do when they get to this point when they're working alone is say, oh, I need to factor and divide. But don't do that. That's multiplication and division. You cannot simplify until you've combined like terms on top. Does that kind of make sense? But you can see how easy that can happen, right? Like, look at this. Oh, I pull out a name. Does that make sense? Don't do it. Okay, combine your numerators. Combine like terms. Here we go. 9m plus 8m is 17m. Negative 63 plus 16 is negative 47. And that was all over m minus 7 times m plus 2. Now, this is the part where it would be appropriate to factor and divide out exact factors. But look, our numerator does not have anything in common. 47 doesn't divide by 17. So that's our simplified answer. Nothing did divide out. All good? Let's do another one like that. This one. Write it down for yourself because you're going to want to refer back to it before the test when we get to the reviews. We want a least common denominator. Now, looking at our denominators, they're all factors. Ready? Like, look, linear factor, linear factor. Then once again, 3c minus 1 is connected. That's an entire factor. So unless this has a 3c minus 1, the only way to get a 3c minus 1 over here is to multiply by 3c minus 1. Then we have a c minus 2. So now, I'm going to multiply by c minus 2, aren't I? Parentheses are very necessary. Then right here, I'm going to multiply by 3c minus 1. Now, this should be throwing red flags in your face because it's subtraction, and that's what people miss. Our next step is to multiply out our numerators. C times c. C times negative 2. Negative 2c, and that's all over c minus 2, 3c minus 1. Now, careful, I'm going to go ahead and say negative 4 times this. Do you see how I'm putting the negative with the 4? I'm going to distribute the negative with the 4. Negative 4 times 3c is negative 12c. Negative 4 times negative 1 plus 4. We've distributed the negative, and that's all over, 3c minus 1 and c minus 2. Now look at your denominators. They're the same, so we can combine our numerator. You have to combine the numerator before you simplify. We have a c squared minus 2c minus 12c. Isn't that minus 14c's? And then plus 4. That's all over c minus 2 and 3c minus 1. Is everybody caught up to me mentally? Now would be the appropriate time to say, does the top factor, factor the top, factor the bottom, divide out exact factors? Did you have a different question? Uh-huh. So we could have done like this too. We could have just said we can multiply 4 and that would be 12c minus 4, right? But then it subtract all that stuff, so that'd be negative 12c plus 4. So we did it with, yes, just to make our life. Okay, good question. Hey, that's our answer then. If the top doesn't factor, nothing's going to divide out. We're done. There's our answer. Okay, let's do one off the worksheet. Go to the back, number 5. We're building up here to harder and harder. So here we go. Least common denominator. Can you tell me it right off the bat? Yep, x plus 9, x minus 10. There was nothing in common, so yes, in this one we did have to multiply by each other's denominator. Let's go ahead and do this. Use parentheses is the biggest thing I see missed, one of the biggest mistakes. If there's 2 terms, it needs parentheses. Okay, I better just throw those in now. What am I going to multiply by here? Yep, x plus 9 over x plus 9. Next step, when doing addition and subtraction at this point, is to multiply out your numerators. 2x, 2x squared, good catch, minus 20x. And that's all over x minus 10, x plus 9. Now looking at this next part here, let's think, should we distribute the negative to begin with? Let's think about this very carefully, because this is where it gets a little bit harder. But that's why we practice so much multiplying out polynomials. So we have technically negative 1 times that, correct? Now remember, isn't it smart to take 2 polynomials and multiply those 2 together, combine like terms, and then multiply in the third? Yes, so let's ignore negative 1 for a minute. Here we go. X times x is x squared. X times positive 9 plus 9x. 5 times x plus 5x. 5 times 9 plus 45. Combine like terms. X squared plus 14x plus 45. And now we'll remember, we're now going to multiply negative 1 to all that stuff. And now I'm going to go ahead and rewrite right here what we get. So negative 1 times x squared, negative x squared, right? Negative 1 times positive 14. Yeah, minus 14x. Negative 1 times positive 45. Negative 45. And that was all over x minus 10, x plus 9. Now, once again, look at your denominators. They're the same. The whole point of doing this was to combine the numerators. We've already distributed the negative through, so we can literally just combine like terms. 2x squared minus 1x squared. Yep, negative 20x minus 14x. And then minus 45, and that's all over. Okay, good. Now we're to the step where we better check to see if the top factors. Because if it does, something might divide out with the bottom. Well, multiplies to be negative 45 and adds up to be negative 34. 1 times 45, 9 times 5, right? 315, I don't see anything, so nope, so we're done. There's our answer. You guys doing okay? Yeah. Okay. Hey, go to number 4 on the front. Now, isn't the rule to when adding and subtracting to get a least common denominator? Yeah. So we've got to be we've got to make the denominators look the exact same. Now what I want you to notice here is this isn't in standard form. So we don't really know what that denominator is unless we rewrite it in standard form. So let's completely rewrite the problem. Here we go. 1 over negative b plus 2. Isn't that what we're really looking at? And then plus b over b minus 2. I just rewrote the original problem. I have not done any math yet. Now, we know to get a least common denominator, we need our denominators kind of factored out, don't we? Is this denominator considered factored? No, because there's a negative. So let's rewrite that denominator factored. What should I pull out? A negative 1. Divide by negative 1, divide by negative 1. Left is b minus 2, isn't it? Then we have plus b over b minus 2. Look at your denominators. What's my least common denominator? b minus 2, which is already in common, and a negative 1. So it looks like the only one we need to fix is this one. Times by negative 1, times by negative 1. So we have 1 over negative 1 times b minus 2 minus b. How did I get minus b? Positive b times negative 1 minus b, right? Over negative 1 times b minus 2. Now the whole point of doing this was to combine the numerator. Wouldn't it be wise to write it in standard form? Okay, let's do it. Negative b plus 1. Does everybody see why I got that? And then on bottom I have negative 1 and b minus 2. Now our last step is to factor the top, factor the bottom, and simplify. The top, what would we factor out? Pull out a negative 1, then left is b minus 1, isn't it? And then on bottom we have negative 1, b minus 2. So what divides out? The negative 1s. So our final answer is b minus 1 over b minus 2. So once again, the reason I've been making you rewrite them is for reasons like this, when that negative really divides out. And you wouldn't have seen it if you wouldn't have rewritten it in standard form. Okay. Okay, I'm going to have you now practice a few before we continue upward and onward into a little bit more difficult and difficult. So try some of that caliber. Ready, go. So you're going to finish up the front, and you could be able to finish that up in like 45 seconds, hopefully. And then on the back, these will take a minute. Check off some with me before we move on. Ready, go. Hey, watch. Oh, you already have this one. Okay, so just watch to make sure you're getting them right. Have you already done 13 and 14? 14 is one. Okay, well, once again, let's go through this. What's my least common denominator? No. Mn. Multiply by n, multiply by n, multiply by n, multiply by n. Am I right? What's my next step? Multiply out the numerator. So don't I have 2n over mn plus 5m over nm. Now, can't I combine the tops? 2n plus 5m. Can I actually put them together? No, they're not the same thing. So we're done. Hey, let's look at this one. What's my denominator right now? So what am I going to multiply by? What's my next step? It's like people are getting caught up on this step. Well, this, nothing happens. So we have 3 over t plus 3, correct? Then don't I have plus, multiply out the tops, plus 15 over t plus 3. What's the whole point of that? So that we can combine the pods. So we have 5t plus 18 over t plus 3. What's getting us caught up? I don't know. Okay. Are we good? Okay, we've got to go on to some harder ones. These are still like very basic, guys. What? No, we'll come back. Oh, no. We're not going to go do that one. Just think a little bit. Okay. Get a least common denominator. You're overthinking that one. Okay, here we go. So, write down this example, because if not, a lot of people get these types wrong. So we have x over x squared minus 5x minus 6, plus 2 over x minus 6. Now guys, to find the least common denominator, you're going to want your denominators once again factored, aren't you? Because guess what? They might already have stuff in common. Now this might contain an x minus 6. We don't know until we factor it. Does that make sense? So let's factor out this. What multiplies to be negative 6 and adds up to be negative 5, 1 times 6, negative 6. Correct. Rewrite this problem. Here we go. We're looking at x over x plus 1 times x minus 6. Plus 2 over x minus 6. What's already in common? X minus 6. So what do we need to multiply by? Okay, does everybody see? All I have to do is come to this piece and say I need to multiply by x plus 1 over x plus 1. Is everybody with me? Yeah. Look at your denominators. Are they the same? Yes, now they are. So what's my next step? Combine the numerator. To combine the numerator, you have to multiply out the numerator. So I have x over x plus 1 times x minus 6. Don't I multiply this out? Plus 2x plus 2. And that's all over x plus 1, x minus 6. Now, we'll combine our numerator. What's x plus 2x? So we have 3x plus 2 on top. On bottom, x plus 1, x minus 6. Now you're to the part where you would factor and divide out any exact factors. Well, we're done. So that's our answer. It doesn't factor. Okay, another one. Write it down for yourself to refer back to. 5x over x squared minus 4 minus 3 over x squared minus 2x minus 8. No, we're not. We're just factoring it, though. We're not going to, like, so far, yeah. Okay. We do not know what's in common until we factor out our denominators. Because they might contain stuff in common, and we don't want to double dip. So let's rewrite this problem. We have 5x over, what does that factor to be? You're right. And then we have minus 3 over, that factor is what multiplies to be negative 8 and adds up to be negative 2, 4 times 2, negative 4, right? So we have negative 3 over x minus 4, x plus 2. Now let's look at our denominators and find our least common denominator. So what do we already have in common? Okay, well that's going to be in our common denominator then. What's left over though? X minus 2. What else is left over? Okay, there's our least common denominator. Yeah, well, no, because do we need our denominator? Once again, no. Do we need our denominators multiplied out? No. What does this one need to make it look like this? Okay, let's multiply by x minus 4. Use parentheses, x minus 4. What do I need to multiply this one by? Okay. Times by x minus 2. Look at the denominators. The same, the same. We're good. The next step is to multiply out your numerator. 5x times x. 5x times negative 4 minus 20x. And that's all over x minus 4, x plus 2, x minus 2. Then right here, negative 3 times x, negative 3x. Careful, negative 3 times negative 2. I've already distributed my negative, and then that's over x minus 4, x plus 2, x minus 2. Now, because our denominators are the same, we can combine the numerator. Is everybody seeing how these steps are every time the same steps? So we would have 5x squared, any other x squareds? Negative 23x, wouldn't we? And then plus 6. And that's all over. Did you see how I didn't multiply out the denominator? Okay. X minus 4, x plus 2, x minus 2. Now you'd say, does that simplify? Well, let's see the top factors. Well, multiplies to be 30, a times c, and adds up to be negative 23. Oh yeah, 15 and 2, you're right, you're listing them out. We are listing them out. 3 times 10. Any others? No. So do you see how none of them doesn't factor? We're good. Kind of glad it doesn't, because then we don't have to simplify. Okay, let's do one off the worksheet. So it is number 2 on the back. Here we go. Let's do it together. To know what's in common, let's factor out the denominator. The denominators, I guess I should say, but that doesn't factor. So here we go. Well, multiplies to be 700 and adds up to be negative 80. 70 times 10, negative, negative. Is everybody with me? Now we're going to drop and break. We've got a long factor, which, once again, I'm going to go quick because I know we already know how to do this. So we have 7n minus 10 and n minus 10. Okay, so that was all just to factor the denominator. Let's rewrite what we're looking at. 6 over 7n minus 10 times n minus 10. Then over here we have plus 5 over 10n. Okay, least common denominator. Least common denominator. That, and that, correct? Okay, so what is this one missing? Okay, multiply by 10n over 10n. What's this one missing? 7n minus 10 and n minus 10, right? Look at your denominators. Are they truly the same? Let's see. Yep. Aren't they the same, everybody, now? The next step is to multiply out the numerator. Here we go. 6 times 10n. 60n over 10n. 7n minus 10, n minus 10. And then when we're multiplying, three things. Wouldn't it be smart to multiply these two, combine like terms, then multiply in 5? Sure? I think so. 7 times n is 7n squared minus 70n, right? Minus 10n plus 100. So then that's 7n squared minus 80n plus 100. Now don't we have to multiply positive 5 to all that stuff? Positive 5 times all that stuff. Here we go. Plus 35n squared minus 40. Oh, that's an 80, isn't it? So then minus, oh, yeah, 400n and then plus 500. Because that was an 80n from these two. Combine what? Where'd I get what? We combine like terms. Negative 70n minus 10n is negative 80n. No, we shouldn't fact, well, till we get to the end, right? What's our next step? Combine like terms, right? With the top. So then that's all over 10n, 7n minus 10, and n minus 10. Does everybody see how I literally just multiplied that out? Okay. Now, the whole point of doing that was to combine the numerators. Let's combine like terms. So wouldn't we have 35n squared? 60n minus 400n. So minus 340n's. And then plus 500. And that's all over 10n, 7n minus 10, and n minus 10. Now we would just check to see if the top factors. Let's divide all of them by 5. Do they all divide by 5? Try that one. What's that divided by 5? Calculator. Don't do it in your head. We are trying to be quick. What? Oh! Okay, we gotta factor out the top then. Okay, so we're pulling out of 5. Is everybody mentally caught up to where I'm at though? Okay. Pull out of 5. Divide by 5, divide by 5, divide by 5. Quick, guys. So then left is 7n squared. You said it was what? Minus 68n plus 100. And that's all over 10n, n minus 7n minus 10, and n minus 10. Okay, now what multiplies to be 700 and adds up to be negative 68? Nothing. So we're done factoring. We would have to factor it, so. I don't think it, no it doesn't, I don't believe. So now, can't I divide out the 5 and 10 though? Oh. Otherwise, there's no point to factoring if we're not going to simplify what we can, right? But do you see how this is just one last step? Okay, my final answer is 7n squared minus 68n plus 100 all over 2n, 7n minus 10, and n minus 10. And we are done. So this is literally just combining so much into one problem. Go to number 6 on the worksheet. Okay, let's go to 6 on the worksheet. Let's find the least common denominator before the bell rings. So we have 7. Shouldn't I pull out a 10? Left is n minus 6, isn't it? Minus 4n over n plus 4. Okay, let's look. What's the least common denominator? We have a 10, don't we? An n minus 6 and a n plus 4. So what does this one need? This one's not bad. What does this denominator need? So multiply by n plus 4. You better put it in parentheses because there's 2 terms. What does this one need? 10 and then n minus 6. 10 and then n minus 6. So this one's going to finish off quite nicely. Now multiply out your numerators. Combine the numerators all over that denominator. You guys get what you're doing next, right? 7n plus 28, am I right? Then right here, wouldn't I do, now order, we're doing negative 4n times 10 times that. Couldn't I put these, multiply these two and then multiply it in here? Couldn't I multiply these two and then multiply it in here? Let's do that. So that's 10n minus 60, isn't it? Times negative 4n. Let's distribute that in. So wouldn't that be negative 40n squared? And then right here, plus, what's 60 times 4? Let's see. Yeah, 240, positive 240 n's, correct? And that's all over 10, n plus 4, n minus 6. Now look, your denominators are the same, so you can combine like terms on top. But guys, do you see how it's literally this? I like said the same thing the past 25 minutes, like hour of class. Like the steps don't change. Combine your numerator. That's you.
Wait, really?
Yep, see ya.
Oh, yeah.
Yeah, but that's only like 8 problems.